Okay, so lesson 2.4 is broken into 2 days of notes. Okay, we've got lesson 2.4 day 1, which is this page, which, as I said, we should reasonably be able to get through. And then the assignment that, for those of you in class, is listed on the board in class. For those of you virtual, I'll have it at the bottom of the page, and it also is listed as the first assignment in Skyward. I believe there's 2 different 205s in Skyward. The problems here go with what I'm teaching today. Okay. I would ask that you do the homework tonight so that you're, doing it based on what I've taught today. However, in an effort to make sure I get through notes tomorrow, we may or may not get it checked tomorrow. Does that make sense? It will be one of those, I want to make sure I get through the notes, so we may end up checking both pages 205s the same day. We may check them separately. I'm not 100% sure yet. Today, if you'll notice, it's long division of polynomials. I know you guys love hearing that. The remainder theorem and the factor theorem. Remainder theorem and factor theorem will be much better than long division, okay? So today, long division. And that's why I want you to do the homework today. Because then tomorrow, I'm going to teach something called synthetic division. I'm trying to think, did we do synthetic division in Algebra 2? I think so. We did?
I remember that name.
Synthetic division is where, well, we'll talk about. Okay, see, I've got someone online saying it sounds familiar too. So it's where basically you drop all the x's off. We have a line of numbers, a number in a box that we're dividing by. So tomorrow we'll look at synthetic. But for today, long division. Now, normally I would do this on the whiteboard. However, I don't want to go to the whiteboard because that means moving the camera and everything today. So, side note, how well do you guys remember your long division skills? Not in the slightest. That's probably a good answer.
36.
Okay, this is a side note problem. This is us practicing our long division skills like what you would have learned back in elementary before I throw in variables at you. Okay, so this is no calculators, by the way, non-calculator problem. Okay, how do we divide 36 into 8,198 without the use of a calculator? So where do I start, Ashley?
You start with the first number underneath the sign.
Okay. So in this...
36 cannot go into 8, so you put a 0 over the 8.
Okay. And
Absolutely blank.
In this case, yeah, so 36, if you just look it into 8, does not go into 8, so you can either put a 0 or leave it blank. I would leave it blank. And in all honesty, because 36 is 2 digits, could we automatically go ahead and look at 2 digits in? You could look at that. So 36 into 81. How many times does 36 go into 81? Twice. So where do I put that to? Above the 1.
Then it's 72.
And now what do I do with that?
You subtract it from 81.
Well, hold on. I'm taking this real slow. We take that 2 and we multiply the 36, right? So 2, and if I think about pieces, 2 times 6 is 12. Carry the 1. 2 times 3 is 6, plus the carried 1 makes it 72. Or, I know, some of you just go, 2 times 36 is 72. Then we subtract, is what I was told in class here. 81 minus 72 is 9. Borrow if you need to. Okay, so once we've gotten a remainder there of 9, then drop down the next 9. And then you repeat the process, right? How many times does 36 go into 99? Twice.
Because 36 times 3 is 108.
Okay, 2 36s is 72. If you're kind of thinking ahead and double checking, 3 36s is 108. So that doesn't work. So this is going to be 2. So now where do I put this 2? Above the 9. 2 times 36, 72. And again, we subtract. 9 minus 2 is 7. 9 minus 7 is 2. Repeat the process one last time. And drop down the 8. 36 into 278. Well, I know 3 36s is 108. So then I can jump to 6 36s would be 216. I feel like it'd have to go at least once more time.
Yeah,
So my guess would be 7.
it is 7 because 8 is 288, but 7 is 252.
Okay. So if we go 7, I'm going to put a 7 above the 8. 7 times 6 is 42. So I'm going to write down the 2, carry my 4. 3 times 7 is 21, plus the carried 4 is 25. Again, we subtract. 8 minus 2 is 6. 7 minus 2 is 2. 2 minus 2 is 0. I have a remainder of 26, which is smaller than my divisor of 36, right? Which is good. We're not going decimals, because when we start dividing polynomials here in a moment, we can't go decimals. How do we express this answer then?
227R26.
Okay, so in elementary, it was 227R26, remainder of 26. So bump it up to middle school years. Fractions. Do you remember how we did fractions?
No.
227 and 26 over 36. Because 36 is the divisor. So that answer becomes 227 and 26 36. Wow, I didn't play that tongue twister. And yes, you could reduce it. That's not the point of this problem. Okay, the point of this problem is, can you now maybe do some long division by hand?
Yes.
Okay. Not going on, into an ongoing decimal or anything, but finishing up with a fraction. Okay. So that was our kind of side note to get us started, because I know long division is foggy, because how often do you guys do long division by hand? Okay. So hold on to those skills, and let's try example 1 here. Which example 1 was use long division to find the quotient and remainder when 2x to the 4th minus x cubed minus 2 is divided by 2x squared plus x plus 1. Okay, so we've done long division before. Well, I say we did long division in Algebra 2, didn't we? I'm thinking surely we did if I taught synthetic. Okay. But you remember having to fight long division. You're probably thinking, really, Mrs. Sargent? Why are you torturing me so? Okay, so what goes where?
Well, 2x squared plus x plus 1 goes on the outside.
Okay. 2x squared plus x plus 1 is our divisor. So that's going to go outside there. Now, stay with me before you write it out. What goes inside? 2x to the 4th minus x cubed minus 2. There's a slight trick when doing long division that makes life a little bit better. And that is making sure that all powers are represented. Meaning, okay, so the first piece in the division is 2x to the 4th. The next term is a minus x cubed. What should come after an x cubed term in standard form? An x squared. If I have x to the 4th, x to the 3rd, the next thing that I should see is an x to the 2nd. Do I have an x to the 2nd in this problem? No. So what can I put in here as a placeholder to represent an x to the 2nd? 0x to the 2nd. Or just 0, but I like to say 0x to the second. I'm not saying you can't do this without it, but it makes life easier if we line it up. What should come after an x to the second term? An x to the first. Do I have x to the first? No, so I'm going to put plus 0x. And then minus 2, because after your x to the first is your constant. Okay, so do be on the lookout. If there are missing place values, you put zeros in there. And the same would be true out here in the divisor as well. Okay, we ready to try this? So, unless anyone really remembers what they're doing here, I have a feeling I probably need to take the lead. I'm going to start, and hopefully everyone can see this, red. The first term in the divisor, and the first term in the dividend, okay? So I'm going to ask myself, and if we think in terms of like our division wording, we usually say, how many times does 2x squared go into 2x to the fourth? Which is a little bit confusing when we are trying to work with polynomials. So when I say, how many times does 2x squared go into 2x to the fourth? What I'm really asking here is 2x squared times what is 2x to the fourth? Are you guys able to see the red okay? Okay, debatable there. No one on virtual is complaining, so. Okay. 2x squared times what is 2x to the fourth? Any thoughts there? X squared? 2x squared times what is x to the fourth? And the correct answer is x squared. So that x squared is the next piece, or is the first piece in our answer. Now, if you couldn't come up with that, you can always divide. What is 2x to the fourth divided by 2x squared? And that is x squared. Now, how many terms were in my divisor here? 3. So how many terms do I need to count in here? 1, 2, 3. So this x squared is going to go over the third term over, because I'm dividing by 3 terms. Does that make sense? 3 terms into 3 terms. Now, I will also tell you, if you're doing this correctly, it's not coincidence that this x squared, our first piece of our answer is x squared, and it ends up lined up over an x squared. That is true also, it lines up over there. Okay. What do I do now? We put the number up top. What did we do in regular division? But before you subtract, I don't have anything right here to subtract yet. I'm going to have to multiply. So I'm taking x squared here and multiplying it by each of these 3 terms. Okay, so x squared times 2x squared is going to be 2x to the fourth. X squared times x plus x to the third. X squared times 1 plus 1x squared. Okay. I multiplied. After I multiply, what do? Subtract. 2x to the fourth minus 2x to the fourth. 0. If it's anything other than 0, you've messed up. That first term has to be 0. That's the whole design here. Excuse me. Negative x to the third minus x to the third. Not 0. Negative x to the third minus x to the third. Yep. Negative 2x to the third. Always remember, we're subtracting that bottom row. And if you'd rather go through and change your signs and then add them, that works too. 0x squared minus x squared. 0 minus 1 is negative 1x squared. Okay. Now what? Okay, drop the next term. Only one term at a time, though. So we're going to bring down the 0x. Repeat the process. This time, it's how many times does 2x squared go into what?
This term. X.
Negative 2x cubed.
Yeah.
So I'm asking myself, 2x squared times what is negative 2x cubed? Negative x? I agree. Does that make sense there? 2x squared times negative x would give me negative 2x to the third. So what about that negative x? It goes where? Okay, it's going to be in the next spot, which actually makes it the fourth term in. And I'm going to put minus x, which is the equivalence of negative x. Notice, negative x is over my 0x term, so I've got like terms lined up. What do I do with this negative x now? Multiply. So negative x times 2x squared. Negative 2x to the third. And that better match, folks. That's the one that has to match. Negative x times x. Negative what? Negative x squared. And then negative x times 1. Negative x. After we multiply, again we subtract. Negative 2x cubed minus negative 2x cubed. That's 0, because that's really negative 2x cubed plus 2x cubed, right? Okay. Negative x squared minus negative x squared. That's 0 again, because it's negative x squared plus x squared. Now, that one didn't have to be 0. That's just by luck. 0x minus negative x. Positive x. 0 minus negative 1 is positive x. And then what do? Drop down your next term, which is the minus 2. And officially, we're repeating that same question one more time. This time it's 2x squared into, what's my first term? X. So 2x squared times what is x? Is there a polynomial or a monomial that works there? 2x squared times what is x? No. And so at this point, up above, it would be kind of like putting a 0 there. You don't really have to put it though. Okay, but it'd be like putting a 0 here. And then this is what? This is my remainder. Okay, we're done. There's nothing else to bring down. This doesn't go, we can't go any more times. So we're done right there. So x minus 2, the official direction said find the quotient remainder. X minus 2 is my remainder. What's my quotient? The thing at the top. Yep, the answer. So the quotient is the x squared minus x. Now, let me ask one other question before we move on. Okay, this is if they ask you for the quotient remainder, there's a quotient, there's a remainder. If they ask you to express this answer, or if they just ask you to divide it, or I think on the first few problems it asks you for an answer in fraction form, how do we put this together as one answer with our remainder included as a fraction? Do you understand what I'm asking there? Right. So if we're giving a full answer, first of all, and I'm going to put it right here, this is my fraction form answer, okay? We start with the quotient of x squared minus x. Plus, we have this remainder, right? How do you express a remainder? We did this on our other problem. We take the remainder and put it over the divisor. So we're going to say plus a remainder of x minus 2 over the divisor of 2x squared plus x plus 1. And I believe that is how you're expressing your answers on 1, 2, and 3, and 5 tonight. Is when they ask you for the answer in fraction form. That's how they're looking for answers. So just kind of an FYI there, trying to prepare you for when I see answers tomorrow. Don't just tell me quotient, remainder this. Put your remainder as plus the remainder over the divisor. Okay? Okay. Questions about long division?
No.
Okay. When I go through to do homework check, whether it be tomorrow, whether it be Thursday, I believe it's 1, 2, 3, and 5 that the book asks you to do long division. So what do I expect to see on your paper?
Work.
The work for long division. Otherwise, I will not give you full credit. Okay? So work to figure it out. Don't come up with, I don't get it. Okay? Work to figure it out, especially when I'm giving you guys the opportunity for questions. See me individually, ask questions if you need to, but let's get this long division figured out. Okay? Now, good news, that was the hardest part of the lesson today, in my opinion. I don't know. I guess some people might think 4 is hard, but it's better than this if you ask me, so. Okay. Let's move on and talk about remainder theorem. Okay. The remainder theorem sounds a little gibberish, but I'll make it make sense. Give me a chance. Okay. The remainder theorem, if a polynomial, f of x, is divided by the factor x minus k, then the remainder is f of k. Okay, I know that doesn't sound easy, but I promise it is easy. So the idea is if you have a polynomial f of x, such as, notice we have a polynomial f of x here in example 2, correct? So if you have a polynomial such as this one, divided by a linear factor, such as x plus or minus a number. Notice these are divided by x plus or minus a number, right? And you just need to find the remainder. The remainder is what you get when you take the function and you plug in the k value. Okay? The k value coming from x minus k. That's where you get your remainder. And there are several uses that we will go over in the next couple of days of how the remainder can help us, just knowing if there's a remainder or not. That can help us. So, let me explain this with this problem. Example 2 asks us to find the remainder when f of x is 3x squared plus 7x minus 20 and is divided by each of these. So we've got A, B, and C. So you could take 3x squared plus 7x minus 20 and you could use long division and you could divide it by x minus 2. And you could get a remainder, yes? That is one way to do this problem. I'm not going to take that option away that, oh, you can't do long division because we want, you can technically do long division here. But most of you don't want to do long division unnecessarily. So the idea is we find f of k. Now the key is, what is k? Well, notice it's x minus 2, right? So we're in the form x minus k. If it's x minus k, and we have x minus 2, what is my k value? 2. It's one of those things where it's always going to be the opposite of the given sign. Another way I think about it is if they give it to you as x minus 2, everybody can easily set that equals 0, can't they? And then you can solve this, and the value we're using is 2. So, in order to find the remainder, we need to find f of 2. That's all we do to do this problem, folks. F of 2 means I take 2 and do what? Plug it in. Yeah, plug it in for all the x's. So this is going to be 3 times 2 squared, or 7 times 2,
minus 20. 3 times 2 squared is 12 plus 7 times 2, 14 minus 20. What is 12 plus 14 minus 20?
6.
Yeah, 26 minus 20 is 6. That 6 is what we get when we plug 2 in, f of 2. That means that 6 is also my what? Remainder. You just found a remainder of 6. I figured you'd like a lot better than long division. I mean, if you prefer, you could divide that out and you would have gotten the remainder of 6 via long division. Most people do not prefer. Exactly. I say most. Okay, so can you guys do B? The factor given that you'd be dividing by is x plus 1. We want the remainder. What do I do? Okay, so first of all, if it's x plus 1, the k value you're using is negative 1. So always think opposite the sign when they give you that linear factor, or just think setting it equal to 0. So I'm finding f of negative 1. 3 times negative 1 squared plus 7 times negative 1 minus 20. 3 times negative 1 squared is? No. No. 3. Okay, so first of all, the square is only on the x value. So negative 1 squared, use your brains, not your calculators. Negative 1 times negative 1 makes it positive 1 times 3, which is positive 3. Okay. Remember, if you plug in negative 1 squared in your calculator without using parentheses, your calculator will shoot back at you negative 1, which is not what we want here. 7 times negative 1 minus 7 minus 20. 3 minus 7 minus 20. Negative 24. 3 minus 7 is negative 4, and negative 4 minus 20 is negative 24. What is this negative 24? My remainder. Okay. And I know you're getting the hang of this, but I do want to do C. This will be helpful here in a moment. Okay. So if we're dividing by x plus 4 and I want the remainder, what do? Yeah. Think about this being x equals negative 4. So we're plugging in negative 4. 3 times negative 4 squared, or 7 times negative 4, minus 20. Negative 4 squared is 16 times 3 is 48. Minus 28 minus 20. 48 minus 28 minus 20. 0. And so we have a remainder of 0. We'll talk about tomorrow how we can do the remainder theorem using synthetic division. Because I'll be honest, this is easy, plugging in the k value and finding your remainder this way. But even better, I usually like using synthetic division to find my remainder. Okay, so that would be an option come tomorrow. But for today, I want us practicing this way. Okay? Questions about the remainder theorem? Okay, let's try factor theorem now. Okay, the factor theorem. A polynomial function, f of x, has a factor, x minus k, if and only if f of k equals 0. I know, it's all this garbly junk again. However, think about this. It's similar to earlier. Polynomial f of k has a factor. So that tells me it is a factor, x minus k, if and only if f of k equals 0. What does f of k equals 0 mean? Remainder is 0. So, this directly relates to the remainder theorem, in that, basically we're continuing from the last one. If the remainder is 0, that means it divides evenly, right? And it is what we call a factor. If you get a remainder other than 0, it did not divide evenly, and so it is not a factor. Okay, and there's a reason we worked all 3 parts of above, because yes, there's some overlap from what we just did. Okay, sorry, I'm trying to get my screen where I want it here. So, example 3, not much room, but we don't need a lot of room. State whether the following are factors of the function f of x equals 3x squared plus 7x minus 20. Stella pointed out that that is the same function from above. That's nice. A, we want to know, is x minus 2 a factor of 3x squared plus 7x minus 20? I'm getting a no here in the classroom. How do we know no if we've done no work? Okay, so if we're smart about this, which I would love to be smart about this, part A up above, we had x minus 2. When we worked out x minus 2, we found out there's a remainder of 6. So, because f of 2 equals 6, that means there's a remainder of 6. A remainder of 6 means it's not 0, and so this is not a factor. Okay? In order for it to be a factor, there has to be a remainder of 0. Easy enough? Okay? So let's try x plus 4. Is x plus 4 a factor of 3x squared plus 7x minus 20? Now I'm being told yes. How do we know yes? Okay, part C from above said that when we found f of negative 4, we got 0. And if f of negative 4 is 0, that means there is a remainder of 0. How do we know it's a factor? If the remainder is 0. What this means is if we take 3x squared plus 7x minus 20 and we factor it using our product of AC method, x plus 4 is one of the factors. That's what it means. And part C. X plus 3, is it a factor? I'm being told no. How do you know? You did the work. Okay. Okay, so my point with that question is, this one where you have to do it, right? It's not provided. So if this is x plus 3, what's the work I do? Okay, because the factor is given as x plus 3, we're going to plug in negative 3. So f of negative 3. 3 times negative 3 squared. What's 7 times negative 3? Minus 20. Negative 3 squared is 9. 3 times 9 is 27. No, not going to say that. Okay, I'm going to keep working. 7 times minus 3 minus 21 minus 20. So 27 minus 21 minus 20 is what? Negative 14, she says. What do you know about negative 14? It's not 0. That's exactly what I wanted you to say. Not a factor. And if it's not 0, it is not a factor. Okay. That's still better than long division, isn't it? And as I said, tomorrow I reintroduce synthetic division. So those of you that remember synthetic division, hopefully nothing else you remember that synthetic division is better than long division. Okay. We have one last problem to do here. This relates to something I taught back in 2.1, no, 2.2, I don't know, maybe even 2.3, one of these other lessons I've taught. Write a function of degree 4, leading coefficient of 2, zeros of 0, negative 5, 4, and 8. Don't laugh at me. Okay. There's my start. It says write the function. All the information is given there. Okay, I agree. There's going to be an x plus 5, an x minus 4, an x minus 8. What do we do for 0? Just x. So we're going to have those 4 factors. And then what's the other piece of information we have to include? A leading coefficient of 2. So a leading coefficient of 2 just means our a value is going to be 2, so we just put a 2 out front. Okay, degree 4, we don't have to do anything with because we were just given 4 zeros. So that will work out there. Okay, so 2 for the leading coefficient. A 0 of 0 is just a factor of x. Negative 5 has a factor x plus 5. 4 has a factor of x minus 4. And 8 has a factor of x minus 8. And guess what I'm not going to let you do? Leave it like that. We're going to multiply it out. That's the hard part. This is either harder than long division or the second hardest thing after long division today. This is the only other thing that I find difficult in today's homework, but this is easier for you guys. Now, when we multiply this, there's a couple of different ways you can do this, but you have to do it in pieces, right? What my brain does, first of all, 2 times x is 2x. So when I did this, and I'm not saying this is the right way or the only, well, it's a right way, but not the only way, is I did 2x times x plus 5. And then I also FOILed x minus 4 times x minus 8, and then multiplied those together. And I just looked at my time, so I'm going to do quick. 2x times x is 2x squared plus 2x times 5, 10x. I'm going to FOIL x minus 4 times x minus 8, x squared minus 8x minus 4x is minus 12x, minus 4 times minus 8 is plus 32. And then I have to multiply. I'm going to take 2x squared times everything in the other parenthesis. Yes. I took 2x and I distributed it to x plus 5. So now, 2x squared distributes to the next parentheses. 2x to the fourth minus 24x to the third plus 64x squared. Now I'm going to distribute 10x plus 10x to the third minus 120x squared plus 320x. Now, because I want to, if you do clean it up, 2x to the fourth stays 2x to the fourth. You end up with minus 14x to the third minus 56x squared plus 320x. Okay, guys, the homework is written down here at the bottom. Do it for tomorrow. I will be honest up front to say we may or may not get it checked tomorrow. We may check the following days, but go ahead and do it so you can do this stuff with these methods. And we'll touch base on the next part tomorrow. Let me know if you have questions. Other than that, have a good day.